Hi future doctors, welcome to the next class. We will discuss in this class AC source. AC source connected for pure resistor. So if you are taking a resistor, only one resistor will be there, that is pure resistor. For this they have connected one AC source. E is equal to E naught sin omega t, otherwise V is equal to V naught sin omega t. This is source of AC. So you can follow either small e or V, that is your wish. If I current is passing through this, according to Ohm's law, you will write I is equal to V by R. Here V is going to be V naught sin omega t divided by R. Therefore, I is equal to this V naught by R. We will write it as I naught sin omega t. If you observe equation 2 and equation 1, here also sin omega t, here also sin omega t. Therefore, both are said to be in same phase. So, both current and voltage are in same phase. So phase difference is going to become 0. They are going to say both are said to be in same phase. Same phase means in which direction? In which direction the source of AC will be there, in that direction this current also will be present. Both are going to represent sine waves only. Therefore, that waves we are going to draw like this. So if it is said to be V is equal to V naught sin omega t. So this value is going to be peak voltage. Okay. So this is time t by 2, t like this, 2t, they are going to draw. This is representation of equation 1. Now how equation 2 will be represented? So that is I naught sin omega t. So where I naught is? So V naught by R. So the dividing V naught with some value. If you are dividing V naught with some value, definitely this I naught value should be less than V naught. Therefore, your curve will be coming like this. Now this one is going to be, this peak value is going to be I naught. Definitely I naught should be less than V naught we have to draw. This is going to be minus I naught. So this red color one is going to be I is equal to I naught sin omega t. This is wave representation of source of AC and alternating current. Now phasor diagram, very important and easy. So what is meant by phasor diagram means voltage and current. Voltage and current, these are scalars or vectors, means these are scalars. But for our convenience, we will represent these two as vectors. How we will draw means the diagram which is drawn between voltage and current in vector form, we will call phasor diagram. So if you are drawing voltage like this, let us say this is V, or V is equal to V naught sin omega. In that direction only current should be there. This is going to be I. So this peak values we are going to call it as V naught. This peak value we will call it as I naught. Both should be in same phase, omega t. So no sir, I will draw like this. Voltage in this direction. Then current also you have to take in that direction. Both should be in same phase, isn't it? But always you have to represent current less than, little bit less than voltage we are going to take. So this is also phasor diagram we can take. But here omega t angle to represent, generally we will take like this. In next we will show like this. So in some books they will write voltage across resistor, VR also they will write. But this is only pure resistor, you can write V also, no problem. So this is about pure resistor when AC source is going to be connected. Next we will see AC source connected for pure inductor. So whenever you are taking inductor of inductance L, which is connected to AC source, V is equal to V naught sin omega t. Call it as equation number 1. Now, these two connected in parallel. Now, what is the induced EMF within this means? E is equal to L di by dt. Now, this EMF should be equal to V. Therefore, L di by dt is equal to, what is V here? V naught sin omega t. Here just negative sign is going to oppose, therefore we are not taking, only magnitude we are taking. Next, di is equal to V naught by L sin omega t dt. So if you want to get current, how much current is passing, you have to do integration. Integral di is nothing but I. So V naught by L, integral sin omega t. Integral sin omega t is minus cos omega t by omega. Already we discussed this, isn't it? Now I is equal to V naught by omega L. This minus cos omega t can be written as sin omega t minus pi by 2. So sin omega t minus pi by 2 is equal to minus cos omega t. So always we will get here I naught. Therefore, I is equal to I naught sin omega t minus pi by 2. Call it as equation number 2. What is I naught here? Where I naught is going to be V naught by omega L. Always denominator term we will get resistance term. Now, what is the resistance term for this inductor means? This inductor is going to apply some amount of resistance to the flow of AC, alternating current. That one only we are calling it as inductive reactance. What is XL now? XL is going to be omega L. XL is called inductive reactance. So the resistance offered by inductor, resistance offered by inductor to the flow of AC, alternating current, we will call it as inductive reactance. Therefore, I naught is equal to V naught by XL. So what is XL means here? Omega L. What is omega means we came to know? 2 pi by TL, 2 pi Fn. F is nothing but frequency of this alternating current. So Indian current is having frequency 50 hertz. In 1 second, this type of waves you will get 50. That is nothing but frequency of alternating current. In America, they are going to use 60 hertz maybe, isn't it? So this is nothing but XL. They will ask graph drawn between XL and F frequency. How it is relation? XL is directly proportional to frequency. Graph you are going to get like this. Next, see the phase difference. Equation 1 sin omega t, equation 2 sin omega t minus pi by 2 you got. Therefore, both current and voltage in phase difference of pi by 2, 90 degrees. Now, who is leading, who is lagging? Who is having minus, it will be lagging. Therefore, current I lags voltage by pi by 2 or 90 degrees. So, current is lagging voltage or current lags EMF by 90 degrees. Otherwise, voltage leads current by pi by 2. Current is lagging means who is leading? Voltage is leading. So, this is about current equation, means alternating current equation, and what is the phase difference, and you got one new term, inductive reactance. Next, wave representation. If you are going to take wave representation, so one wave directly, always this is common for all. So this is going to be V is equal to V naught sin omega t. This is going to be plus V naught, negative side minus V naught. Now, how you will represent I is equal to I naught sin omega t minus pi by 2. Current is lagging, therefore, it will be lagging 90 degrees. It will be going like this. So, this dotted line is going to represent I naught sin omega t minus pi by 2. So, what is the phase difference between these two means? Minus pi by 2. This value is going to be peak value I naught, where I naught is nothing but V naught by XL. So, next phasor diagram. Phasor diagram, if you are representing voltage in this direction, Now where we have to represent current. So if you represent voltage in this direction, where we have to represent current means current lags. This is going to be I. So this is going to be I naught. So current lags. How much it lags means? This is omega t. Phase difference between these two should be 90. So therefore, remaining angle omega t minus pi by 2. So that is nothing but phasor diagram. So current lags. If you have taken this voltage here, this current here we have to take. So always voltage should lead, current should lag. That is the phasor diagram. So next we will see capacitor in our next class. Now you can practice this pure resistor and pure inductor when source of AC is connected. Thank you.